Excellent. Welcome to episode 108. So apologies in advance if it all goes wrong technically. This is only my second time with the restream controls. And before we started, I was saying it worked really well last time I did it, and then Eric was telling me all the things that went wrong last time he did it. So now I've got fingers.
And it did go very wrong when we were trying to set up just a couple of minutes ago. But
Yeah,
luckily we made it on time.
yeah, that too. Yeah, there's
Yeah,
all
there's
there's
a whole.
always an audio issue every single time.
Yeah, it was a little interesting. Like the first time I hosted it, seeing all these different controls. It's like, oh, what happens if I click that? What happens if I click that? And I'm one of those, like when I was a kid growing up, that my mom would always be like, oh, don't touch the buttons. I was a total button pusher. If there was a button, I had to push it.
When I was attending one of the during COVID times, one of the online conferences, we all had access to the back office for speakers and people managing the stream, and we were instructed to click the big red button at the end of our talk once we are done responding to questions. The thing was, we all had kind of admin rights, and there were two buttons next to each other, and the one button stayed, close session and close stream. And as you can imagine, once you are in the heat of the moment, you are looking for the red button, you see the first one, you click, and we were supposed to go end session, but many people would click end stream, and it would literally just kick everyone out for the whole track. So there's things we can learn, even from the UI perspective.
We could probably do a whole insight session just on how to use the thing, right?
Yeah, I had a similar comment where they said, whatever you do, you have the right to push the red button. Don't push the red button. But you're so right, Eric. There's so many buttons here, and it's so tempting to just go to right. And now I will stop. And I've got it out of my system now. And we should probably start talking about Quarkus rather than streaming platforms. So we have a special guest today, which is really cool. So we've got Greg from Hazelcast, who's going to talk about what he's been doing with the Quarkus extension for Hazelcast, and just talk about Hazelcast in general, and really whatever you want to talk about. And we can introduce ourselves too. So I'm Holly Cummins, and
I'm Eric D'Andrea. Holly and I have worked together a couple times. We did an awesome talk together at DevOps Belgium a few weeks ago. Super psyched about that. And then this, I don't know, I guess I'm pointing up here, but I don't know if that's how it actually is on the stream. That's how it looks like to me. And that's Greg up there.
Yeah, that's correct. So I'm Greg. I'm a lead architect at Hazelcast, which means that I have like a broad view over multiple projects, and I get to contribute whenever there is need. And pretty much for the last year, I worked pretty much exclusively on the new product, Hazelcast Viridian, which I will probably tell you a few words later on.
yeah, before you start, can you tell us a little bit about just what Hazelcast is, and what problem it solves? Because I think probably some people watching will be completely into it, and some people will be going, Hazel, what? Is it edible?
Sure. Sure. So the story of Hazelcast is pretty long, because the tool has been on the market for quite a while, but it did go through quite an interesting pivot recently. So Hazelcast originally was a cache, was Java-centric cache. It slowly evolved into a polyglot IMDG, in-memory data grid, which is a very fancy word for like in-memory distributed storage, where you can also run compute, not just store data, but do some interesting computations on top of it. But on the side, we also had a Hazelcast Dread project, which was a real-time streaming engine. And they were kind of side to side, but there was interesting realization that we made some time ago. Hazelcast Dread relied on Hazelcast for a very long time. It depended on Hazelcast. So if you wanted to use real-time streaming capabilities, you would need to pretty much have Hazelcast running alongside Dread to make it happen. So if those technologies are so coupled together, let's actually not pretend those are two separate projects, but put them together. So Hazelcast at 4.x was still an IMDG, and there was a separate streaming engine on the side. However, since 5.x, we created one single product, which is both capable of running classic IMDG workloads, plus it has a pretty efficient real-time streaming engine inbuilt into that. And if you combine those two technologies into place, suddenly it's no longer just a cache or this in this commoditized market where which is pretty tightly occupied right now. But now you can not treat it as a as a tool that you use just for caching, but also you do some interesting stuff with this data. And that's also a great idea because that move to combine those two projects together, especially while maintaining backwards compatibility, because 4.x with 5.x, it's not fully backwards compatible, but if you're running basic caching use cases, and this is backward compatible for those. So if you migrate from 4.x to 5.x, well, you still might be using it as a cache or just IMDG, but you have real-time streaming engine in there. And now we can go to our clients and tell them, look, this is so much cool stuff you can do with when it comes to streaming. And the best thing is that you already have a setup for that. You just need to start using it. So you can start using that cluster you already have, not just as a cache, as a storage, but for streaming. And you are already set up to do it. So you can actually make it as a central part of your system, as being key operational piece of your software, and not just another data store.
Yeah, that's really nice, because I think probably all of us feel a little bit that, you kind of look at the list of possible tools that we could have in our architecture now, and there's so many things, and you end up sort of, it's like the world's worst Lego set where you're sort of just trying to put everything together, and having some things that have that combined capability and that deeper integration are nice.
So since you already see some questions, some people are asking about Redis versus Hazelcast. People quite often tend to compare one technology with the other, but the whole story that I just described is a good example. It's a good explanation why those technologies shouldn't be compared anymore. Because if you compare Redis versus Hazelcast, and you can compare them just looking at the IMDG and distributed data store capabilities, where in Hazelcast we want to position as technology that does something more. So yes, we can go and compare how those data stores, perform, or internal architectures and so on. But at the end of the day, Hazelcast is a different product that shouldn't be compared anymore to Redis.
Yeah, that makes sense. And we've got another question as well from Guy. So we're starting to get questions coming in, which is super. So can it be deployed? Yeah.
So can it be deployed in embedded mode inside multiple Quarkus services? So yes, it can, as long as you are not running in, if you are not using native images. Well, we'll get to that. So answers to such questions should be pretty obvious once we start looking at the extension.
Cool. Yeah, that's probably a good moment
Good
then to go
segue
on.
into let's look at the extension.
Yeah. And maybe before you start, sort of at a high level, I think Quarkus extensions fall into two categories. One are things where it just wouldn't work, particularly in native mode, if someone didn't write an extension. And then there's sort of another category, which is it works fine without the extension, but it will be so much more awesome, or it works great in dev mode, or it has some other enhancement with the extension. Where does the Hazelcast extension fit?
I mean, technically, you could make Hazelcast work without an extension, but, well, I will show you in a second. Cool. that would require quite a lot of hacking to make it work.
Yeah.
But what needs to be understood is that the Hazelcast extension is just for the client. Running Hazelcast, IMDG, and streaming engine in the native mode could bring some benefits, but the amount of effort needed to get it done is enormous, while not bringing that much of a benefits. So, for example, since Hazelcast is used to storing data, so let's say the overhead of a single JVM instance is, let's say, 300 megs. But in a member, you might store, multiple gigabytes of data. So if you can trim down, 200ths of that, that's not that big of a difference relatively. The same when it comes to the startup time. So the problem it's not a big issue for a Hazelcast member to start up. Even if it starts in 10 seconds, it's not a big deal. Just like with your database, probably you don't care about how you start it once and it runs for a very long period of time. So you don't really care that much about super low, like a couple of milliseconds startup time. However, that's relevant for the client. So if you are running your application and you want to connect to a Hazelcast, that's where super low startup time actually matters. That's why the Hazelcast client extension focuses only on the client side and not on the member side. Plus, at the same time, if you start thinking about internals, it would be extremely hard to ensure comparable performance to what you get from the raw JVM. Hazelcast was written in a way that's optimized for standard JVMs. So if you suddenly try, if you apply quite a lot of hacking on top of internals, which rely heavily on quite a lot of dynamic features and all of those that are hard to get right in GraalVM, suddenly you are running, for example, on different garbage collectors, which were not benchmarked for, not planned for, not accounted for. So this changes quite a lot of things. So whereas it could bring performance benefits, it's a big unknown, and would pretty much need to retrigger the whole. You might need to revise the whole architecture of the Hazelcast internals to ensure that it works, comparably in the native mode. Plus, we are also planning quite a significant rewrite of the internals. Now, Hazelcast is the way it works internally is based on the stage event-driven architecture model. We are planning to do quite a complex rewrite to a thread per core. And that would require quite a significant development effort to make sure that it keeps running on in the native mode. So that's why we made the decision to focus on the other client side.
Yeah,
I
that
think
makes
that's
a lot of sense.
important too.
I wish we had
Sorry.
like infinite time.
We need to be able to raise our hands, right?
Yeah, because what we see like with Quarkus, there's the sort of the startup time and the lower footprint, and I think you're right, those would be pretty marginal when you have something that's so data intensive. But then we also see that the throughput is better, and we don't talk about that as much. And so I can imagine that actually, and one of the things that we do is we take a lot of that dynamism and we sort of front load it to build time, and then you get a runtime benefit. So it could be that actually you'd get even more benefit for running the main Quarkus, but I can see that you get more benefit, and all you need to do is spend a year re-architecting it so that all of the tricks are replaced by different better tricks.
Plus, keep in mind that at the point where the extension was developed 3 years ago, and at the point in time it just wasn't possible. So technically, it was possible, but the product would be so heavily stripped down from features that it wouldn't make that much sense. Now, the GraalVM has evolved a lot during those last 3 years. So there's way more support for dynamic features of JVM, but still achieving better throughput. This is doable, but again, working with the fact that you need to deal with totally different garbage collector, which was never benchmarked, never planned for. It would be kind of really hard to maintain the internals of Hazelcast in such a way that it gives you optimal performance in both models. That's extremely tricky and extremely developer and time intensive.
I'd say too, like I have this conversation with people all the time. It's like I equate native image to like what Kafka was a few years ago. Like it's this shining widget that's flying through outer space and everybody's chasing it and says, oh, I got to do it because everybody else is doing it, even though it may not necessarily be the right use case for what it is, what problem they're trying to solve. So, everybody's like, oh, I got to do Kafka. But when you actually look at what they're trying to do with it, it's like, wow, a traditional message broker probably fits your use case a whole lot better than Kafka does. And I see native very, very similar to that.
That's also why I'm answering the question directly. That's why we are not supporting embedded mode in the extension. We are just focusing on the client. It's quite likely that it might work because Hazelcast evolved a while, GraalVM evolved a while. If you try it, it might work, but probably you will see it in a super limited fashion. So officially it's not supported.
Yeah, makes sense. Yeah, at your own risk, and good luck with that. And
since I'm here already, let me share my screen and maybe let's have a look at some interesting stuff. By the way, that's the new service we just released, Hazelcast Viridian. So if thinking about Hazelcast members, fine-tuning it makes you nauseous. Viridian in Viridian we created a project which is supposed to be like the opinionated version of Hazelcast available right away from in the cloud. So
Nice.
the abstraction layer the abstraction that you're supposed to work with is data. So technically we call it serverless, but if you would like to be a bit more specific, that's memberless, because you are not supposed to worry about how many members you have and what the setup is, but you just worry about how much data you want to pipe in. Anyway, so again, you can work with Hazelcast and Quarkus in native mode without the extension. But let me show you what it means, what it would mean for you to work it, to create it to hack it by yourself. So there are two aspects to that. The first one is the processor and the runtime replacements. So the one that we look at, the processor, it's not that complicated if you start looking at that. There are many items, but still, if you wanted to run something by yourself, you are likely to be actually confused, because probably well, you need to have some knowledge about internals if you want to get this right. So one of the first out of obvious challenges is that Hazelcast relies quite a lot on custom implementations of interfaces and abstract classes. So if you'd like to run some server-side computations, we need to provide Java code, which means there are some strategies, extensions, factories, listeners, and so on that need to be recognized dynamically at runtime, or by reflection, and that's pretty tricky. And it's not very difficult to make it work on native. It's just those need to be listed explicitly. And as you can see, there's quite a lot of those, because, for example, you have interceptors, listeners, and so on. And that's where you register pretty much the whole type hierarchy. I believe this could be simplified. I think the newer Quarkus versions, they had build items that could make it a bit easier. You need to remember about some trivial stuff like pointing to files that need to be available. You need to remember that some of the classes need to be runtime initialized and not build time. And as you can see, there's quite a lot of them. And it's anything from, like some random load balancer event queue plugin to random picker, and thread local random provider. And there's interesting story with those, because I managed to spot a GraalVM bug, which was quite interesting. And the way the bug looked like is that there were certain random classes or the random methods that should generate random numbers, and they would. But the problem is that if you generated native image and you would rerun the same application again, the seed would get actually build initialized and imprinted in the image. So you would get the same sequence of random numbers on each application run.
So don't use it for your highly sensitive cryptographic applications, at least.
Yeah, and but this was a long time ago, so it was fixed. I think for like 2 years already. Anyway, this is easy stuff, right? Because you just need to, and you just list all the potential classes that need to be initialized at runtime or discovered by reflection. You still need to remember about a couple of native flips, which is probably a bit harder to remember about. Register all the potential data, serialization infrastructure. And as you can see, that's not that bad, but there's just a lot of unnecessary code that users probably shouldn't write by themselves. However, it gets a bit more tricky if you start looking at the runtime substitutions. So there's quite a few of them here. Some of them are super easy. So for example, like JCache detector, JCache is not supported, so we just override certain methods and just return false. Okay, that's easy. But if you look at something like service loader and service loader utils, that's getting pretty tricky. And I have quite an interesting story. Took me a lot of time to debug that one. So we've had issues when I was developing the extension. We've had issues with the discovery of config files, but it would be would be quite an interesting setup. So if you had a configuration file of Hazelcast embedded in a different jar, and if the jar was a part of your application, that configuration file wouldn't be discovered. And the issue was pretty interesting. I'm not sure if it's here. Names, not really. But the funny issue was that there is no concept of jars and dependencies once you go into native image. It kind of gets all inbuilt into the binary. And the issue was that somewhere deep inside Hazelcast code, we had lines that were responsible for traversing dependencies and trying to discover configuration files. And since in native image there is usually this hierarchy of jars and dependencies, if you try to resolve a file by location, you would get a URL, but that would point to the actual resource, but if you try to print the actual URL, it would give you quite a bogus value, and quite often those would overlap. So you might have a couple of URLs to discover config files. They would have all the same URL, but if you try to read the content of an URL like that, you would get different values. And inside the Hazelcast, we would use a set and not a list, which means that, and the set would compare using the URL, the value that's repeated is the same for all URLs, despite the fact that they would point to different files. So that one took me a lot of time to find. However, that's not quite a common use case to have those dependencies, like config files in dependencies, but this happens. Sometimes people want to use that. So again, debugging that and trying to figure it out and prepare GraalVM substitutions, that wasn't fun. I mean, it was fun, but for users that want to just use the tool, probably it wouldn't be considered fun.
Yeah, the moral of the story is that if you're going to use this kind of stuff, you need a friend with you. You need a framework and you need the extensions so that they can be finding the subtle behavior differences rather than you.
So as you can see, for example, there were we needed to rewrite some of the reflection methods to method handles, plus some methods. I don't really remember what was the main issue here, but okay, I know. Not all the reflection methods, classic reflection methods, would work just fine. Some of the methods wouldn't work, so you need to use different signatures that would work in GraalVM 19 dot something. That might be not needed now, but it's still not fun. As you can see, those are fairly simple, like JMX Publisher, because those are just not supported. But loading service definitions for the sake of loading extensions, because, for example, imagine you want to work with Hazelcast and Hibernate as a second level cache. So there is some service loading involved. So, yep, you need to write your own and substitute the original one. And we also have one single method that replaces some of the unsafe utils. There were more of those here. There were some issues with the fork pool being used, but luckily over time, those got removed as GraalVM, as those were natively solved at GraalVM level. So as you can see, you could still use that. You can still do it by yourself, but this, as you can see, is kind of tedious to do on your own.
Yeah, definitely some heavy lifting there. What was the sort of the time frame between when you decided that, or when Hazelcast decided to write an extension to actually getting it released? Was it like well, clearly it wasn't 2 days because you had all those things to deal with.
It's hard to say because we were not working on that full time.
Yeah.
I think it took us around a couple of months, but that wasn't, like five from 9 till 5 effort. It was a bit less of that, but a couple of months in general. But I believe, if you wanted to have it done faster, that was an option.
Yeah. Yeah, makes sense.
So as you can see, this is pretty interesting. But besides that, there's nothing really, not really special here. Just a convenient code that makes it a bit more convenient for you to configure it, so that you don't need to craft your own YAML or XML files, but for example, just rely on the application properties file that you get with Quarkus applications.
I mean, that's a huge thing too. I mean, regardless of what an extension does, just like kind of unifying configuration to a single place that's consistent with everything else is, at least from a developer's perspective, is huge.
However, we don't support everything through application properties. If you look at all the knobs that can be, changed, and all the flips and knobs of Hazelcast, those are really huge files. So if you, for example, Hazelcast default, will it pick it up? Client default. Nope. There should be available the client default full. So for example, full example of a client in YAML, all the knobs that you can set are pretty much here. Look on the right. Look as I'm scrolling. So we didn't expose all of that via Quarkus, only those most used ones.
Yeah, and to be fair, I think that's really consistent with the Quarkus way of doing things in general, which is, like you were saying earlier, to be opinionated and to optimize for that 80% of really common cases, so that and that has two benefits. One is, if for someone like you who's writing an extension, it means you don't need to handcraft all of that config and try and keep the two in sync. But also it means that for someone reading the documentation, it's a bit less overwhelming to kind of see the 62 billion options, and it's just, okay, here's the things that I'm going to need to change. I can hold it in my head.
That's also the reason why we created our cloud offering. Because if you start thinking about being successful with Hazelcast, you need to be able to answer quite a lot of questions. So, for example, how many members do I need? How many backups do I want to have per each partition? Do I want to have them synchronous or asynchronous? Do I want to have persistence on? Do I want to have perhaps HD memory? That's one of our enterprise features. What's the ratio between native memory and heap memory? And if you start thinking in the cloud and Kubernetes now, should this be a deployment? Should this be a stateful set? It adds even more dimensions to that. Which serialization protocol should I use? There's a set of questions that you need to be able to answer. So we figured out, but if you want to really try it as fast as possible and the easiest way possible, you just go to viridian.com and you start thinking about, you create your cluster and you start thinking about data. I want to process or store, let's say, 2 gigs of data. And serverless gives me that right away. Scruffy young guitar. Okay, that's nice. And pretty much after a couple of seconds, you have a cluster ready that will auto-scale for capabilities. So you don't explicitly state how many members do you want. You don't state how many backups do you want. You don't state if you want persistence. This is kind of set up in an optimal way for you. In the future, we are planning to have some customizations, of course. But if you want to just try, use, and you don't really have any specific use case in mind, that's a good starting point.
Do you think the pattern will be to start that way and then go to running something on premises that's more customizable? Or do you think actually, if you have that available, there's that, you wouldn't necessarily ever want to switch off it?
There's one very good reason why you'd like to go for. Oh, I turned it off. There's one very good reason is that, so for example, here I'm running on the free mode, which is, I don't remember which number, but there's a certain threshold of data that you can process for free, at least for now. Because the offering, we released it not that long time ago, and it's still running as in the preview mode. There's one very good reason. It gives you all the enterprise features right away. So you don't get your own license, but you get to use those features right away. Plus, we are experimenting, and the next-gen architecture of Hazelcast will be exposed via cloud directly as cloud first. So that's also another reason why you would like to try that out first. But generally, whenever people don't want to abandon, their local setups because people don't want to abandon their local setups because, well, now you need to connect a remote machine to be able to debug it. It's way easier if you have it locally. So what we try to do with Viridian is to make the local experience as close as it gets. I mean, to the cloud experience as close as it gets to the local one. So, for example, if you are, I don't have a setup for that. I didn't plan that, but so we have a Maven plugin. So if once you connect as you create your cluster, you connect, you download a new project right away. It has a Maven extension, Maven plugin, which requires a key and secret that you find in your account. And once you provide it there, you can conveniently upload your own code to Hazelcast whenever there is needed, or you can also access logs. So working with embedded Hazelcast was super easy because you could, you run it immediately and you see the logs directly in your console. But you can do the same with here. You download the project, you run it, and you access, and you see the logs being streamed directly into your terminal, which is as close as it gets to the local experience. So I think that this should be one of the options you'd like to experience it in the future. Okay, let me show you how it works. I mean, not Viridian, but the extension in general.
Cool.
So perhaps we should start with starting our own Hazelcast cluster. I have some shortcut for that. So if you want to benefit from auto discovery of Hazelcast, and if you want to run it in Docker, you need to provide one extra incantation here to make it work. Because by default, if you don't do it, Hazelcast will bind to internal IPs of containers, and it won't be won't be discoverable. So we want to bind it to the local IP. So let's run it. Let's maybe run one more. Okay, the port looks fine.
Yeah, can you make that font a little bit? Actually,
yep.
Can you make it a little bit bigger? And actually, can you
Yep. Yes. But those logs luckily won't be that much relevant. So, it's a bit too big. Anyway, but what's important from that is that you can see it running. There's Hazelcast cluster running in the background. You can see that it formed a cluster, and there are two members in that. Second one is represented here, and that's pretty much all that you need to know about that. So there's a Hazelcast cluster running in the background. So now we should throw in some Quarkus. So we can just generate the. Let me download it to the desktop to not mess up with other. It was this one. Let's see. Is it here? No. D? That's how I called it? Let's see.
We're developers. We're really good at naming stuff, right? We always have the best names for things.
Was it this one, really? Yep, it was that one. Okay. I wonder, was it name chosen by default, or did I click something along the way? Anyway, so let's open it. Trust it. Okay, so we have a standard project running with nothing much in there. So if you want to add the extension, there's this command line. There's the command line incantation that you can use, but we'll do is the old school way. Quarkus Hazelcast client, com Hazelcast. And yes, we'll use the snapshot because Hazelcast 5.2 was released recently, a couple of days ago. So the new updated extension is not yet released, but it's on the way. Anyway,
I too have done demos with extensions that only existed on my laptop.
No, don't say that.
It does exist in the GitHub repository. It's just not released yet. Anyway, so let's say, so now what we need to do is that you need to be able to point to a Hazelcast cluster that's running, and that's that IP that you want from here. And in order to be able to do that, come on, where are you? You need to add just a simple line of code here. So that would be Quarkus, Hazelcast client cluster members. As you can see, there is the auto-completion, works pretty nice. You just point it at the member. The client is smart, so if you have to point suddenly to one, it will auto-discover all of them, and you should be able to use it right away. So let's see what we can do with the default project. There's this greeting resource that does hello. Let's inject some Hazelcast instance into that. And we should be able to use it right away. So perhaps let's go for hello plus HZ. Let's get a non-existing map with non-existing value. We'll fill in those later. Obviously, there's no value in there, but we should be already able to see that the extension actually works. So if we go over to terminal and go for dev mode, and give it a second. Release versions unsupported because probably I'm running on JDK 11, right? So let's go for 17.
That was exciting.
Did we lose him?
Yeah, that was the special feature. Oh, here, we've got him. We've got Greg back now.
What
Special
happened?
Hazelcast feature dropped me from the live stream.
If people knew that we had a Quarkus extension that got you out of meetings, that we would have
Quickly.
some-
With very little memory overhead.
Yeah. All you do is you start this feature. Right. Shall we have a look?
Okay. Let's see if this thing works. So I have doubts now. So yeah, right. So let's switch the application to the different port. Port. Yep, let's go for 8081. Let's rerun it. Let's hope I don't get kicked out again.
Interesting that the streaming software thinks it's running on 8080. It's a weird port.
Or I wonder
It might be 5005.
Yeah, 5005.
Oh no, it's running.
Yeah, get something. So my theory is it's another instance of another Quarkus or something somewhere that was sort of for prep, and then it got.
You want to curl the 8081 port, right? Your curl's still going to 8080.
Oh yeah.
All right. Yep. Okay. Okay, that works. I mean, the null was expected because we didn't really do anything yet because our greeting reserves looks like that. But as you can see, we already managed to connect directly to the application. So if we are in the dev mode, which means we can start playing around. So let's make it simple. Let's create a copy. Let's make it hackathon grade. So for example, we get the map. We put hello message world. It's terrible, I know, but good enough. Because what we want to do effectively just put something in there and see if it pops up. So let's go for hello 2. Oh wow.
You've got 2 endpoints at the same URI path. You need another.
Oh yeah, right. That's a very good point. So let's perhaps create another one here. So we'll have a path hello 2, right? So hello 2. Yep. We go for hello 1. We don't see anything because what?
Because your put key is hell message instead of hello message.
All right. Thank you. Yeah, but it's a nice opportunity to see how the dev mode works. So
Yeah.
let's go for hello 2.
On purpose.
Nope. Put hello message, it's the same world. Who this matches. Interesting. Let me have a look at the. I don't see anything alarming in here. I know it's a mess. Don't try to read it even. But I know what to look for. There's nothing alarming in here. Let me try to rerun it. Did we miss anything? I don't think so. Come on. Come on. No, still running. Let's give it a second.
It's taking a while to come up, isn't it?
Yep. I hope we could still try the native image in a second. However, we need to get ready for a couple of minutes of build time, so we could chat meanwhile. And okay, what's going on? Are they in use? I mean, 8081 is still in use. Okay, interesting.
Could try 8080.
Let's try once again. So anyway, while this is happening, we can also try the native binary meanwhile. But again, so we will need to wait those 3-4 minutes, so we'll get a chance to chat. So anyway, right? The point is, once you have your extension available, and you should be able to. Yeah, I'm expecting the same to happen. So let me actually try to access some previous logs. Once you see the startup happening here, you see that Hazelcast client extension is loaded. That means that it's available right away for injection. So as you can see, I didn't do any special configuration of Hazelcast. It's just the extension was added and I can inject it right away. If you're running everything in not in Docker, you don't even need to add the address of a member because it should be able to discover what's going on, what's happening locally. But if we're running our instance in Docker, that's necessary. Okay, that does not work. Okay, let's go the easiest way possible, 8082.
when this is all over, you're gonna have like 5 different like daemon processes sucking up ports on your machine for one reason or another.
I'm hesitant to start killing all of them because I don't want to kill the stream by accident again. But what I see this is that looks like it's not going to work again, which is interesting. Yeah. Okay. You know what? Let's go directly for the native mode, because this is going to be, since we'll be running this in Docker, this will be a bit more isolated. Should be a bit easier. And we'll still get a chance to talk about the extension, although we have like 10 minutes left. Let's copy those magical lines directly from here. So we'll package it as we'll use the container build, and we'll package it as a native. And let's hope that my machine can stream and generate native image at the same time. Because yeah, this is going to take a while. Normally it's probably 2 minutes, but with my laptop being streaming at the same time, this is probably going to be a bit slower.
So
oh
yeah, sorry, go on.
And so perhaps you didn't really have the chance to do that, but once we were once we tried the first time the application, you could see that it took significant amount of time to initialize. So once the application was running, once you issued that GET request, it would take a while for, okay, test failures. Okay, that's true, because there are test failures because let's just delete them, because we don't have Hazelcast. The tricky part about running, so we also have the part of the extension is the annotation that will wire a Hazelcast instance for you. However, if we have Hazelcast instances running in Docker bound to a host, they might start getting auto-discovering each other, and this might get tricky. So let's just get rid of the tests and go directly for the binary. So once, even in that first case where we're still able to run something with the HTTP GET, you could see some delay because you need to wait for the Hazelcast client to initialize, connect to a cluster, and then process that simple GET input. This happens naturally just once at the very beginning, but on the first request, this could be noticeable.
So it sounds like
okay.
that. Oh, failed again. I was going to ask you a question, but we can wait until we debug this.
Oh wait, didn't I remove that?
Maybe, yeah, clean.
Well, you're trying to run the tests, and the tests are looking at the hello endpoint. It's looking for hello rest easy, and you changed it, so the tests are failing.
Yeah, but the test
got
deleted.
Yeah, but I didn't do the clean.
Yeah.
So
it makes me sad.
The difference will be, the difference is huge, because if you try to, so if you'll see, once we run the native binary, you will see the application starts immediately, a couple of milliseconds. But it doesn't really initialize the client yet. So you will see no logs related to Hazelcast client. Those happen only on the first, when you first time actually do touch. Okay, that's dangerous. This happens only on the first, when it's the first time you try to access the class, the world endpoint, which actually touches the Hazelcast client instance. And that will be blazingly fast. So you will see the answer pretty much right away without that the tiny delay that was noticeable at the first time.
So I wanted to ask you, because you were mentioning how if you omit the configuration, it will auto-discover Hazelcast instances on your local network. And so it sounds like that's kind of the same, but kind of quite different to what Quarkus would often do, which is to use dev services to spin up something in test containers, but that would be just a test-only instance. So what does Quarkus, does Hazelcast have any support for running via test containers, or does it sort of fight too much with that auto-discovery?
Oh, it's very, no, so the auto-discovery is just a Hazelcast, is just pure Hazelcast feature. So to make it a bit more clear is that if just like you've seen here, I created 2 instances in Docker, and they formed a cluster pretty much right away without any extra involvement. So they use multicast to communicate and pretty much broadcast what's available and where. It works the same way with the client. So if you are not running this all in Docker, this will pretty much right away work. You will create a cluster, and if you create a client right away, it will find that cluster and connect to it. So that's the part. So this applies only to scenarios where you have cluster already running somewhere on your local machine. So for tests, test containers would be preferred, and Hazelcast pretty much is very easy to run in test containers. So there is no separate module. You might want to just set, if you're running Docker, you might want to set 1 or 2 knobs, and that's pretty much all.
So it sounds like that might be something then sort of on a wish list for the extension in the future, is to have that dev service. So that, yeah, if there's nothing configured and there's nothing on your local network, that it will spin it up.
So what we already do have, in the extension, where is it? We have that test framework, but it's a very simple one. It effectively just starts up, just a simple embedded instance of Hazelcast and makes it available for you to use. That's super trivial. But that option with test containers sounds good. And generally, there are like 2 camps. Some people think that since Hazelcast works in embedded mode, just use it in tests. But my preference would be to still go for separate deployment in Docker. The reason is that if you're running on production, quite often you have most enterprise customers are running client server topology, where you have server running somewhere on the side and you connect to it right away. If you're running in embedded mode locally, just for the sake of testing, you are quite likely to not experience problems that you would experience on production. A very simple example: imagine that you are trying to use a class that's a part of your class path of your application, but not a part of the class path of the server. If you're running your test in the embedded mode, it will work because it's still the same JVM and same class path. But it will break if you go to production. But if you run your tests in Hazelcast, which is Dockerized, it will fail again because there will be a separate class path. So that's my preference as well. I'd rather you run tests against Dockerized cluster and not embedded mode.
It's kind of similar to the conversation about, when you test against the database, do you use something like H2 when you run your tests, or do you actually use like a real Postgres, MySQL, whatever database you're
Yes,
running?
the difference being that both are real Hazelcast.
Yeah.
So the Hazelcast server and in embedded mode, that's the same real Hazelcast, but with different configuration. Running Hazelcast in embedded mode is it's okay. It's not like it's worse than running client server. So there are, for example, cases where you want to use where you have quite sophisticated real-time streaming pipeline. Sometimes it's easier to have a very tiny application that pretty much creates a Hazelcast embedded instance and pushes a job in there than having this job being delivered to a separate Hazelcast cluster. Sometimes it's just easier to form a cluster from applications, which is just a pipeline. So this is also a valid use case. However, again, for testing, I'd rather test with a setup that's as close as it gets to the production one. And if there is not much trade-off, so it's not much harder to have your Hazelcast to run it in Docker for the sake of testing, especially with test containers, then go for it, because this is more likely to work on production than if you'd be using embedded setup. But if you're planning to use embedded setup on production, then it's okay to use embedded in testing. Anyway, so took us 5 minutes. That's a lot. Normally it will be around 2 minutes, probably around 1 minute on my M1 Pro. So where is that? Okay. So magical lines are in here. So we want to build a Docker image from that. We want to run it. And we want to run it, which port? Let's say 8083 was free, right? Oh, as you can see,
Now,
it did run really quickly.
yeah.
Wait, but we have a problem because it did start on 8082. Wait, so we need to go
'Cause we
for...
config, didn't we?
Yep.
Yeah.
Yep, that's the big issue. As you can see, it starts right away. As you can see, there are no logs indicating that Hazelcast is running or connected to anything. So let's try to do that hello. And we got hello null. And right away, as you can see, all that initialization happened really, really quickly, which is really pretty cool and pretty impressive, because on the first time when you are connecting to a cluster, you would expect this to take way more time. And that's also why we think that providing an extension for client brings way more value than for the server. Because if you are running client application that's using client to connect to a cluster, that's what you want. You want blazingly fast initialization and being able to connect. But when your cluster is running, if your startup time doesn't matter that much, let's say you are performing, controlled restart of members. You still, when you run rolling restart or rolling upgrade, you are not likely to perceive the downtime with Hazelcast anyway, because you do it one by one, and it is 1 or 2 seconds, even that's not a big deal, because the time will be spent anyway on realignment and repartitioning and not on the bare startup time. But here, that's where the bare startup time matters. And I think it's clearly visible.
Yeah, that makes so much sense. And just when you think about what it's doing, a slow cache is something that nobody wants. And so then it's the client side that you want to be seeing those improvements on. And it is so fast. That's really cool. So I guess we've got about 3 minutes left. So this is a good time for any last minute questions on the stream, if anybody has any. Or if there's anything else that you wanted to show, Greg, or any sort of roadmap or upcoming features that you wanted to talk about.
So I can. So let me preemptively, tell you about the things that we're planning. So Hazelcast up to this point, as you can see, was heavily Java centric. But what we are trying to push in last months and years is to not require for non-Java developers to write Java code. So, for example, if you want to define streaming pipelines, you need to use Java APIs for that. But this is slowly replaced by our SQL engine. So streaming jobs will be able to be defined by using SQL. If you wanted to run one of the popular caching topologies, like write-through, read-through, you still needed to write quite boring Java code to be able to read data, for example, from some data source. But with 5.2, we figured out, okay, let's make a generic implementation where you just need to provide configuration and it will happen for you. And there are a lot of many small improvements that we've done to make sure that if you don't want to write Java, you won't need to.
Nice. Yeah, I think that's so good, isn't it, in terms of making it more flexible. So you have the sort of if you want to do it, you can. And if that's not your thing, then it's just stripped down to the bare config in whatever form you do want to interact with it in.
At the end of the day, if you are a Java developer, it's not a big deal for you to write some Java code. But if you're a Python developer that's forced to write Java code, well,
then it's the worst.
It might not end up well.
Yeah. Awesome. So I think we've got probably about 30 seconds left. And I don't think we've got any more questions. So anything else from you, Eric?
No, I definitely learned a lot. I've worked with I haven't worked as much with Hazelcast, but I've worked with other things in my history. So it's definitely, I learned something. Never too old to learn something new, right?
Yeah, and do let us know if you ever figure out what was eating your ports, because I really want to know. As soon as you sign up the stream, the mystery will be resolved, because that's how demos go. But it was interesting what was going on there. So yeah, so thank you very much, Greg. Recording will be available. If people want to know more, what should they do?
So if you want to know more, definitely you can head over to the GitHub page of the extension. You will find a bit more notes about that. If you want to learn a bit more, you can still join our community Slack, where me or others will gladly answer your questions if you didn't get a chance to ask it now. Also, it's pretty easy to find if you Google Hazelcast community Slack. Yeah, I believe you can do it.
Excellent. So with that, I think we can close the stream. But yeah, thank you very much for the demo. Yeah, as Eric says, really, really interesting, and I learned a lot.
Thank you. My pleasure.
See you all.
See ya.